In this section, we're going to talk about descriptive statistics. So we're going to apply this to numerical data. This can also be called quantitative data. So data is just a list of words, characters, numbers, anything that portrays information. So for example, here, this would be numerical data. So we're going to look at these 15 exam scores from a fictional statistics class. And the idea is that this is data. We have these individual scores from each student in that class. And in this case, it's numerical because it's numbers. You might see data in words sometimes. That would be called categorical data, but we're going to focus on what we can do with numerical data. So first thing we're going to look at is graphing this data. And there are many different ways to do this, but we're going to focus on making something called a histogram. So a histogram is a type of graph, and it works really well for large sets of data, which here we're working with a fairly small one, but it'll come through of how it kind of works with grouping, and it'll group values into these different bins. So we're going to be working with this bin width of 10. You might see terminology that says class width, which would be the same thing. It's basically telling us what increments that we want to separate our data by. So if we're separating by 10, then what we're going to think about is separating into 10s, 20s, 30s, 40s, 50s, so on and so forth. So we'll have these grouping by 10s. So what we're going to need is a grid. So we're going to have a grid here, and then we'll set it up like we do in algebra in terms of having an X and Y axis. We'll be focused on just being in the first quadrant over here, and that we'll mostly just have positive values coming through for our data set. Now the X-axis is where we want to graph our data values. And what we're going to do is to set up this X-axis. So in our case, this is going to represent exam scores. So to figure out what values we need to see, we can look back at our data, and we need to see everything from 30 up to 100. So I can get an idea of how far I need my number line to go. And then what you also want to use is the class width or the bin width, and that would tell you the scale to use. So what I could do is start labeling here. I could go 10, 20, 30, 40, so on and so forth. But I want to show you a little trick here too, because with what I'm graphing here, I don't have any data between 0 and 30. So we're going to end up with this kind of, it's not a big gap, but it's a bit of a gap. And you can imagine, say we were collecting larger values, say our data started at 300. You wouldn't want to have to show everything between 0 and 300 as blank. So something you can do, and that's not the worst way, we could have written it all out, but I just want to show you this way that we could jump to 30 and then start using our units of 10. So 30, 40, 50, 60, 70, 80, 90, 100, 110. But something we need to be careful of is now I have these kind of two increments. Here it's 0 to 30, so it has this like distance of 30, and then it changes to distances of 10. So because of that, we can use this tool called a line break that lets us jump up the x-axis, and it allows us just to move along our number line without having to graph all of this blank space. So this symbol here just shows there's nothing between 0 and 30. All of the important information is going to happen here. Now for the y-axis, we're going to label the y-axis as frequency, which frequency just means counting how many values are in that bin. Counting the number of values in that bin. So this is going to set the height. So with the histogram, we're going to see this bar being graphed, and the bar is going to span, like in this case, 30 to 40, and then the height of the bar is going to match up with how many data values are in that set. So for labeling, I'm going to write frequency. And then I'm just going to number by ones. So 1, 2, 3, 4, 5, 6, 7, 8. So that sets up our histogram. So we haven't actually graphed anything yet, but that sets up the axes. So let's go to our data set and figure out how we're going to separate this data. So I'm going to have these groupings by 10. So I'm going to have the 30s, 40s, 50s, 60s. So with that, I'm going to separate my data. So 30s, I can just kind of cut there. That's everything that I have in the 30s. So I have one value in the 30s. 40s, nothing. 50s, nothing. Then I have 60s, 70s, 80s have a lot, 90s, and then hundreds. So I have 2 values in the 60s, 2 values in the 70s, 6 values in the 80s, 3 values in the 90s, and 1 in the 100s. So making my graph down here, for the 30s I have 1 data value. So how I'm going to graph that is I'll have a bar that goes between 30 and 40, and it's going to have a height of 1 to represent that 1 data value that's landing between 30 and 40. 40 to 50, nothing, so we aren't going to graph anything there. Same thing, 50 to 60, that'll be blank as well. 60s, we have 2 data values, so I'll have this bar with a height of 2. For the 70s, also a height of 2. 80s, a height of 6. So I'm going to go up to 6 and down. And then 90s, a height of 3. 100s, and I think I off by 1 here. I am. Sorry, mistake on my part. I meant to leave 2 boxes blank. Okay, one more time. I'm just going to leave that in there. 2, 2, 6 for the 80s. 90s, 3 data values. And 100s, 1 data value. There we go. So that's our histogram there. So this works really nicely for large data sets because we end up collecting values in these bins. And with that, we can get a quick display of how the data values distribute over this number line. Now this number line that we're working with here, we call this a continuous number line because we can see every possible value and every possible decimal place here. We could graph anywhere. So with the graph itself, it's hard to see the exact data values. It does just give us this overall trend for what's occurring. Like without seeing the data set up above, I couldn't tell you the exact numbers, but I can give an idea of, okay, for exam scores, 1 person was in the 30s, 2 in the 60s, 2 in the 70s, 6 in the 80s. So we can get an idea of, wow, a lot of students scored in the 80s or like at B level. And we had a decent amount in the 90s as well. But then this value out here, the 30s, we can see it's kind of separated. It's behaving a lot differently than the rest of the data. So with a histogram, it gives us this overview of how that data distributes. Now with these bins, if you think about graphing the individual data points, so like graphing 65, 65 is landing in this bin here, and it's being represented by one of these boxes, and the other one is being represented by 62. And it doesn't matter which one is which, really. It's just this overall, in the 60s, there are those 2 values. So this bin right here, or this class, it's covering everything starting at 60, going all the way up to 70. But something I want to make sure you notice is the data value of 70 itself is actually being graphed in this bin. So 70 as a value is landing on the edge of that bin, but when a value's on the edge of a bin, it always goes into the right-hand bin. It's called the right-hand rule. Right-hand rule that just says if a data value lands on the edge of a bin, it goes into the right-hand side. So really, in terms of a number line, what's being graphed here is everything from 60 up to 69.9999999. Like we're getting very close to 70, but not actually including 70. And then the next bin starts at 70 and goes to 79.9999999. So with these bins, they kind of start at this whole number and they end right before the next edge of the bin. So that's our histogram. And once we get the histogram, what we could start doing is talking about the shape of the graph. The shape gives an idea of trends that are at work with the data. So one thing we could talk about is the mode, and specifically like how many modes there are. So mode just means the most frequent data value. And with that, how that's going to come through in the graph is that'll be the peak of the data. That'll be where it hits the highest point. So with our data set up here, it was this class of the 80s that was the mode. So what we can do is kind of get this overall idea of the trend of this data set, and it has that single peak. So that would be an example of unimodal, just has one peak. And in fact, we're going to look at a few different ways that that unimodal graph can occur when we get to shape. So when we get to shape, we'll look at all of the different unimodal graphs that we can see. But some important ones that we can see with mode is the case for no mode. This is also called the uniform model. And this is where there isn't a peak, which means when the data is graphed, it's relatively flat. Something like that for a histogram. So what that's doing is there's this very even distribution of data, and with that we won't see this come up too much just because it's not particularly interesting data, because what we want to end up getting at is where is the data centered, what do we expect for our data, and how does it spread out. And with the uniform graph in terms of what's expected, well, we could land anywhere. It all has kind of this even probability of occurring, this even distribution. So there's not much to be said for that. When we get to unimodal data, then we can start talking about the center of the data and how it spreads out. Bimodal and multimodal data, we want to be careful of this because this suggests subpopulations. So let's talk about how this comes through. So bimodal would be the idea of two peaks. So we'd have some histogram that maybe builds up to a peak, and then maybe it decreases out, and then it's going to have the second peak. Now they don't have to be the same height, and often how I think of it is like a roller coaster. It's the fact that it's building up and then dipping out, and then building up and then dipping out. Doesn't matter the height that it goes, it's just kind of this, is it riding this wave? And multimodal would be the same idea with 3 or more peaks. So maybe something like this. That would be multimodal in that this would kind of follow, in this case, decrease down, increase up, decrease down, increase up. So you'd have these 3 peaks there. So these are 2 types of graphs, and these relate to subpopulations, and that's going to come up again down here in terms of graphs we want to be careful of. We want to be careful of graphs that have subpopulations with them. In fact, I'll go ahead and describe what makes it subpopulations. So let's say we collected data. Let's go with this multimodal graph. Let's say I had you go out to a grocery store and collect information about the fiber content of bread. So you would go to the store, grab some random loaves of bread, and look at how many grams of fiber per serving for the different breads. What we might see if you collect all of that data is something like this. And it's because there are these subpopulations based on type of bread. We have white bread, we have wheat bread, we have multi-grain, things like that. And And these types of bread have very different kind of trends for fiber content. White bread is typically low, wheat is typically kind of medium, and then multigrain is usually high fiber content. So what we would see with our data is we could see this trend of where white bread's behaving, wheat bread, multigrain bread. So in terms of looking at this graph and talking about center and spread, we don't really want to look at this data altogether because there's this characteristic that's actually separating our data and separating these populations. So what we would rather do is maybe just focus on wheat bread. So separate that data and look at it as its own unimodal graph. So just looking at this piece and talking about center and spread for wheat bread, or separating just multigrain and looking at the trends of multigrain data. But looking at it all together at once isn't very beneficial. So we might see bimodal and multimodal graphs, but we want to be careful of them, and it often suggests that we should separate it. For shape of unimodal data, so for a single peak, we have symmetric data. And this will be data, I need to draw bigger here. This will be data that forms roughly a bell-shaped curve. So if we think about the trend of this data, it should be roughly symmetric. And with these, you kind of don't want to look too closely. It's kind of like if you stand back and look at it, what's the general trend of the data? So it might not be perfectly symmetric, but if it roughly has this peak in the middle and this overall kind of increase and decrease nature around it, that would be symmetric. Then what we want to look at are these two types of skewed graphs. So skewed graphs is going to have this tail of data to the left-hand side, and then we'll see most of our data on the right-hand side. And then skewed right is where we'll see most of our data on the left-hand side with a tail of data to the right. So something we're going to talk about are outliers. That's our next piece here. And those outliers tend to come up with these skewed distributions. And outliers is a term for extreme data values. It's like data values that aren't behaving like the others. And typically those will come through in these kind of tails of data where we have these separated values that aren't behaving like the rest of the data. Same thing here. Now, these outliers are important because they're going to have an effect on our mean and standard deviation, which we'll go through in the next videos. And with these outliers, what they can do is skew those values. So it's the outliers that are causing the skew. So a common mistake is to switch these up because when you read like skewed left, you're thinking it's describing where all the data is. But the skew is actually coming from these little values out in the tail, these values that are extreme and separated from our data set. So if you ever forget which is skewed left and which is skewed right, just think, where is the tail? Where's the tail of data? And the side that the tail of data is on, that'll be your skew direction. So we want to be careful of outliers, and we'll talk more in the next videos of how to deal with outliers and properly represent them and even find values that are exactly outliers. And then we want to be careful of subpopulations, which come through in bimodal and multimodal data sets, because I would suggest that we should actually separate up our data. So that's how we make a histogram, and then that's how we can talk about some of the different shapes that go with that.